Hello everyone. Here I am again with a question from double integral section 15.1. The question asks evaluate the double integral of this function y e to the power negative xy on the region 0 to 2, 0 to 3. So the point, when you have double integral, the important point is that you have to make it to iterated integrals. What we need is Fubini's theorem, which says if your region is of this form, then double integral of any function with two variables is nothing but iterated integrals. So you either do x first, then y. So if x is first, then is y. So these are boundaries for x, these are boundaries for y. Or you can do y first, then x. Again, boundaries for x are these guys, boundaries for y. So you either do that or that. But which one is better here in this specific example? I'm going to do first one, first dx, then dy. So basically now I am down to double integrals. From double integrals, I'm down to the iterated integral, and then the technique is just do integrate inner one, then outer one. So let me start with the inner one. dx. Y is constant, so it is like e to the negative 2x. So what you do in this situation, if you have exponential with multiple of y, so you basically use the substitution. U is equal to negative xy, then du. Note that I'm doing everything in terms of x. Y is constant, so I'm going to have minus y. I don't need, okay, let's do the whole thing. Then I have to change boundaries too. If x is equal to 0, then u is going to be 0. You just multiply, you get 0. If x is 2, then you get minus 2y. So my new integral is going to be from 0 to 2y. Oh, I have, when you integrate with respect to x, I get minus y dx. So I have y dx in my integral. So let me just write like this. Y dx together gives me du with a negative sign. So I have that. Then this is e to the power, the whole thing here is equal to u. Now, basic integral table says that integral of antiderivative of e to the u is e to the u, and fundamental theorem of calculus tells that you can do evaluate function integral by just doing evaluating function on this part minus the lower one, and that's what. So my inner integral, I did that. I got e to the power 2y minus 1 dy. So this part is done, and I just plugged in there. Oh, the boundary is from 0 to 3. Now I have to find the antiderivative of e to the 2y. Antiderivative of e to the y is e to the y. Antiderivative of e to the 2y is half of e to the 2y minus y going from 0 to 3. So plug in there, half of e to the 6 minus 3 minus half of e to the 2 times 0 is 0 minus 0. So the result is half of e to the 6. This is 3 minus half. It's going to give me 5 over 2. Oh, sorry, it's negative. Both of them are negative. So I get minus 7 over 2. So again, remember that when you have double integral and your region is of this form, you have to use Fubini's theorem, put them in right order, then do the iterated integrals. And here is a challenge for you guys. Try to evaluate the other order, which is this guy. And remember that you will need your integration techniques. In this specific case, you will need integration by parts. Have a great day. Thanks.